Greetings, geometry students. I appreciate you finding time to get your notes taken care of. Today we're going to be looking at another formula hopefully you are already familiar with through your travels in junior high, and that would be the distance formula. So please copy down the title as well as your objectives. Our stated objective for today will be to acquire basic vocabulary, understanding, and workings of the distance formula. We're going to be doing an activity again, and you will demonstrate the ability to utilize the distance formula while completing that class activity. And your essential question for today is, can I find the length of a line segment in a graph? As always, anytime you need more time to get your notes copied down, simply press pause and then hit play when you're ready to move on. Okay, so let's take a look. Now, same basic information as yesterday, but please go ahead and copy it down again. Remember that any location in a two-dimensional coordinate system has an ordered pair x, y that describes its precise location. Okay, so we've looked at the Cartesian coordinate graph, which is what this guy is called. Remember, our horizontal axis is the x-axis. It is positive moving to the right and negative moving to the left. And our vertical axis is the y-axis. It is positive moving upward and negative moving downward. Anywhere that you can pin a point in this two-dimensional plane, it will align somewhere with both the x-axis and the y-axis, and wherever those alignments take place, that is the location of your coordinate. In the case of this point that I just plopped up on the screen, it will have a negative value aligning somewhere on the x-axis and a positive value aligning somewhere on the y-axis. Okay, so for any 2 points, and same as yesterday, in order to keep the confusion down to a minimum, we use two different labels, point 1, which lives at x1, y1, and point 2, which lives at x2, y2. There is exactly one line segment that connects any 2 points that exist in the plane. That line segment that connects those 2 points has only one possible length, and that length is the result of this formula. Now again, formulas are difficult to remember, so the key is going to be to verbalize what this formula actually says. That's when our brain will begin to understand it. But the formula itself has a gigantic radical over the top of it. And underneath the radical, we have x1 minus x2. The result of that difference is then squared. And then we add the difference y1 minus y2. And then that is squared. Okay, so verbalizing that formula, basically what we have is the difference of the x's squared plus the difference of the y's squared, and all of that is underneath a square root. Okay. All right, so taking a closer look at the formula here, if we are looking in a graph, we have 1 point. It aligns somewhere with the x-axis and also with the y-axis. We would call that point 1, and it lives at x1, y1. We have another point somewhere in our graph. It would align with the x-axis and the y-axis somewhere, and we would call that point 2, which would be at x2, y2. And there is only one line segment that possibly connects those 2 points. The length of this line segment can be found as the result of the distance formula. Now, it does not matter which one is point 1 and which one is point 2. if you plug them in, one of you, like if one person is using the left one is 0.1 and the right one is 0.2, and somebody else is doing it as it shows on the screen, you will temporarily have some sign differences inside of the formula, but then once the squares that are built into that formula do what they do, we will all end up with the same positive values, and we will end up with the same distances. Now, distance is a length. Lengths are always positive. There's no such thing as a negative length, even though some mathematicians do tend to argue that there is such a thing as negative length. If you were to walk 15 steps in one direction, that is a positive value. So what does it mean if you turn around and walk 15 steps back the other direction? Well, it's still a positive value, positive distance. It just happens to be in the opposite direction. Okay, so distance is a length. Length is always positive. The result of your distance formula will never ever give you a negative value. Okay, so let's take a look at some examples. Chances are, if you've worked with this formula before, these are the type of problems that you have seen. Find the distance between points 2, 3 and 4, 1. Now we're going to employ the same two strategies that we did yesterday. We will always, anytime we have all these points going on, we're going to take our two coordinates and we're going to label them. We're going to label one of the coordinates x1, y1, and we're going to label the other coordinate x2, y2. It does not matter which one is 0.1 and which one is 0.2. We will all end up with the same answers as long as we don't make any mistakes. And as always, anytime we use a formula, we will write that formula down. Again, we take all the time and trouble to write down the formula and to label the points because we are not very good at trying to plug information into formulas in our heads and then write down the result of that. Sorry for the squawking in the background. That's my dog and my cat fighting. Anyway, we've got our formula written down. We have our points labeled on our paper, all right there in one place together. It virtually becomes impossible to not install the information into the formula correctly. Okay, so let's plug in the information. Okay, we copy down the formula exactly the way that it is written. The formula calls for x1, so we go to our coordinates and we see x1 is a 2 and we write it down. x2 is a 4, we write it down. y1 is 3, we write it down, and y2 is 1 and we write it down. Okay, so just plugging into the formula exactly the way that the formula calls for the information. Now, as we move through the math, we are going to be interested in the information inside of the parentheses first. Okay, so in those two little binomials there, we're going to deal with the 2 minus 4, which is negative 2, and the 3 minus 1, which is positive 2. The next order of business will be to square those two values inside of those parentheses. Now remember, to square something means to multiply it by itself. So negative 2 squared means to take negative 2 and multiply it by another negative 2. Negative 2 times negative 2 will be 4. And on the right side, 2 squared, positive 2 times positive 2 is also 4. It is just a coincidence that those two values happen to match up and be identical. They could have been any values. The next step would be to simplify underneath the radical. 4 plus 4 is 8. Now later on this year, as we work with the Pythagorean theorem, we will learn to simplify this radical down into simpler terms. But for now, we will leave that value alone, and that is our answer. The distance from 2, 3 to 4, 1 is the square root of 8. If we needed to know exactly how far that is, we could input that into our calculator and get the decimal point that goes along with it. But for right now, this is okay. Okay, let's look at another one. This one asks, what is the length from A to B if A is at 0, 6 and B is at negative 3, 2? Okay, same strategies as always. We're going to take our two coordinates and we're going to label them x1, y1 and x2, y2. Once again, it does not matter which one is which. And we will always write down our formula without anything plugged into it. Okay, now we're going to plug our information into our formula where it says x1 is going to be 0, x2 is going to be -3, y1 is going to be 6, and y2 is going to be 2. So just plugging those in as pieces of information right into the formula. Now again, the first thing we are after is the parentheses. Okay, so on the left side, 0 minus -3. Okay, well, minus negative, double negative means positive, so that actually says 0 plus 3, which is 3. And on the right side, 6 minus 2 is obviously 4. Okay, now we're interested in squaring those values underneath the radical. 3 squared means 3 times 3. That is 9. And on the right side, sorry, the doorbell just rang, 4 squared is 4 times 4. That is 16. Okay, next thing we're interested in is simplifying underneath the radical. So 9 plus 16, that is 25. And 25 is actually what we call a perfect square, meaning is the result of a whole number being multiplied times itself. So this one we will simplify. What number times itself equals 25? Well, obviously the answer is 5. The distance between 0, 6 and -3, 2 is exactly 5 units. So if we have a perfect square underneath our radical, we will go ahead and simplify it down into a whole number. But again, we'll learn how to work with those radicals a little later on in the year. Okay, one more example. Okay, this is more in line of what you're going to be doing with your activity. What is the length of the line segment connecting A and B? Okay, so in this particular case, they did not come out and give you the information about the coordinates for A and B. They are simply located into a graph. It is up to you to determine the coordinates and then apply the distance formula to find out how long that line segment is. Okay, so looking into the graph, we have a point at 1, 5. Remember, the x information always aligns first, and then the y information, x comma y. It's alphabetical. So 1, 5. And then we have point B at -2, -4. So we'll label those guys x1, y1, x2, y2. We will write down our formula as always. Okay. Then we will plug our information into our formula. Okay, so in this case, x1 is 1, x2 is -2, y1 is 5, y2 is -4. So simply recording the information into the formula. Now you work inside the parentheses first. 1 minus -2. Double negative makes positive there. So that's 1 plus 2. That's going to be a 3. And another double negative on the right. That will be 5 plus 4, which is 9. Simplify the exponents next. 3 squared will be 9. 9 squared will be 81. Add the values together. 9 plus 81 is 90. And we'll stop and think if there is a whole number, some number times itself that will equal 90. We're checking to see if 90 is a perfect square or not. There is no whole number that will multiply times itself to equal 90, so it is not a perfect square. So for now, we will let that be the final answer. Okay, so take a moment and jot down your summary. Note any questions that you may have. And keep in mind your essential question, can I find the length of a line segment in a graph? I appreciate you finding time to get your notes taken care of. I apologize for all the background clutter that was going on in the audio today, but that's just life sometimes. Anyway, I will see you in class.